This is a shiny app to calculate levels of contaminating prekallikrein activator from chromogenic assays. The underlying kinetics have been explained in the notes and video for the zymogen activation reaction app, which can be found in the Shiny Clots webpage. Briefly, this is a one-pot reaction in which a zymogen, prekallikrein, is activated by a protease, prekallikrein activator, to produce another protease, kallikrein. A chromogenic substrate is also present in the reaction mixture, which is hydrolyzed by the kallikrein protease. This type of assay is used in quality testing of clinical batches of albumin and immunoglobulins to determine the level of contaminating prekallikrein activator. More background can be found in the references given in the Help tab of the app. At the early stages of the reaction, the production of kallikrein is approximately linear over time. This means that the rate of cleavage of chromogenic substrate is constantly increasing, which leads to an observed exponential increase in absorbance. In practice, to calculate the rate of prekallikrein activation, i.e. the zymogen activation rate, it is necessary to replot the absorbance against time squared. The rate of prekallikrein activation is then calculated from the slopes of these plots. A standard and traceable calibration to the WHO International Standard for Prekallikrein Activator is included in the assay so that calculated rates can be converted into international units of prekallikrein activator. The main body of the opening page opens with the Plots tab and a set of data which is loaded when the app launches. There is an 8 by 12 figure of 96 plots from a microtiter plate assay. Data points are shown in red and calculated slopes are black lines. In this example set of data, the plate is split in two halves. In the upper half, rows B, C and D are complete reaction mixtures containing a source of prekallikrein activator, prekallikrein substrate and chromogenic substrate. In the bottom half of the plate, in rows E, F and G are reaction mixtures that do not contain prekallikrein substrate. These wells are used to measure the amount of pre-existing kallikrein in the test solutions. The rates due to pre-existing kallikrein are subtracted from the corresponding wells in the upper half of the plate, which include prekallikrein substrate. Below the plots there is a table of results. The default settings show these results as rates of absorbance change versus seconds squared, calculated from the plots. Because the rates are small numbers, they have been multiplied by 10 to the power 9 for convenience. In the left-hand panel there are options that can be set to change the way results are calculated. There is an option to include a time delay which is added to the data to account for the time from reaction mixing in the wells to the time of the first reading in the plate reader. The next two input boxes deal with the extent of the data to be used for calculating slopes. So you can select how many points to include and a maximum absorbance. These selections are important to allow you to limit substrate consumption. Consumption of both the prekallikrein substrate and the chromogenic substrate should be kept below 10% in order to get the best approximation for initial rates of zymogen activation. You should be aiming to have enough points to get a good estimate of rates over an absorbance change of 0.1 or 0.2. Your selections will depend on how much activity you have in your samples. By default, the checkbox called Use Time Squared is selected because this is a zymogen activation assay. However, the wells that are used for blank subtraction, in this example in the bottom half of the plate, will not look linear as time squared plots. This is because they are not measuring a zymogen activation reaction. The subtraction of the reaction rates in these wells from the top half of the plate is done on raw data, point by point, so do not worry about the nonlinear appearance. The checkbox for 0 at time squared is also selected by default and helps with presentation. This option may also affect rates slightly because it controls the range of absorbance selected. You should decide how you want to deal with this option and stick to the selection. Overall, it will not influence the end results very much because it will affect the standard and test samples in the same way. The Show What option prints the results or well names or well numbers in the plots panel, which is helpful when selecting blocks for subtraction. Below these check boxes are two input boxes that can be used if necessary to subtract rates from reaction mixtures that contain prekallikrein substrate. This option may be required if the prekallikrein substrate contains contaminating kallikrein. If it doesn't, you can leave these boxes with the default setting of 0. If you need to subtract a kallikrein activity, you can specify a well that contains a sample of prekallikrein substrate with chromogenic substrate to give a blank rate. Or if you know what this activity is for your batch of substrate, you can enter a rate in the box as shown here. The final set of options in the left-hand panel deal with how to subtract the block of wells that contain the reactions without prekallikrein substrate. To reduce any effects arising from uneven plate heating or pipetting errors, for example, it is good practice to vary the layout of the plate. The app allows you to set where the top and bottom blocks, or the left and right blocks start in the plate. In the set of example data that loads when the app launches, there is a top-bottom arrangement. In addition, the top row, wells 1 to 12, and the bottom row, wells 85 to 96, have been left empty to avoid edge heating artifacts. Thus, in this example set of data, prekallikrein activation takes place in a dose range of 3 dilutions of activator in rows B, C and D, while the corresponding no substrate blanks are in rows E, F and G. The start of the reaction and blank blocks, coupled with the options for top-bottom or left-right subtraction, offer plenty of flexibility for plate layouts. Finally, at the bottom of the main panel of the Plots tab, there is a table of settings which can be copied and pasted into records to show what options were selected to produce the results obtained from your analysis. The second tab available in the app is called Curve and allows you to focus on individual wells to optimize your settings. This is where you can best see the effects of adjusting the number of points and maximum absorbance to achieve good rate calculations over linear portions of the time-squared rate plots. Further guidance is provided by using the option to plot residuals and the calculations of R². The third tab simply presents the raw data, and finally the Help tab gives a brief summary of how to use the app. More detailed help notes are available from the Shiny Clots web page, which also includes links to other apps, help notes, videos and published papers. Of course, the whole point of the app is to analyze your own data. When you are comfortable with the settings in the app, you can select your data file using the Browse button in the top left corner. From here you should navigate to your CSV, text or Excel file of data and open it in the app. The file type is automatically detected. If you are using Excel files, you can specify a sheet number where your data are. The data format should be one column of time followed by any number of columns of absorbance readings. All columns should have headings, time, A1, A2, etc. as shown in the Raw Data tab of initially loaded data. Good luck!